So here I got t equals logarithm 0.24 for the base of 0.66. So I will use the calculator. The base is 0.66 and I need logarithm 0.24. So the time is 3.43 hours. You can have it decimal, it's fine because it's time. You can have it decimal, don't round it up or down, just leave it like that. Now question E. They said here in question E, before that they said it takes 2 hours and m minutes for the number of bacteria in the second experiment to reach 19,000 bacteria. So they gave you the time and the number of bacteria will be there. Okay. Find the value of m. They need how many minutes? Giving you an answer as an integer value. Integer value, that means no decimal. Integers are positive and negative numbers, but no decimals. So I would plug in ST with 19,000. This is question E. 19,000 equals 5,000 times 1.65 to the power t. Let me find the time now in hours. I would isolate this. So divide both sides by 5,000. So 19,000 divided by 5,000, delete 3 zeros with 3 zeros with 3 zeros. So 19 divided by 5 is 3.8 equals 1.65 to the power t. This is an exponential equation. I would take logarithm for both sides, but the base is 1.65, so I can delete this. So now the time is logarithm 3.8 for the base of 1.65. So I need to round here. 3.8. So logarithm, the base is 1.65 and I need logarithm 3.8. 2.665. 2.665 hours, right? They said here, they said it takes 2 hours, but m minutes, I need to know how many minutes. So the number of minutes is this, so 0.665 hour. Let me transfer it or convert it into minutes, so I have to multiply it by 60 because every 1 hour is 60 minutes. So 0.665 times 60. 39.9. I would round it up because it's time, which is fine to round it up to add time. So it's 39.9, which is 40 minutes. This is M. Question E is done. Now there's question F. They said the bacteria in the second experiment are growing inside a container. The scientist models the volume of each bacteria in the second experiment is this. The volume of each bacteria. And the available volume inside the container is this. How long it will take for the bacteria to fill the container? Now, they gave you the volume of each bacteria and here the volume of the container. Let's divide the volume of the container by the volume of each bacteria and see how many bacteria it will fit. So let's solve question F. So number of bacteria that can fit in the container is, let's divide 2.1 times 10 to the power negative 5 over 1 times 10 to the power negative 18. 2.1 times 10 to the power -5 divided by 1 times 10 to the power -18. So the number of bacteria is 2.1 times 10 to the power 13. That means I would move the decimal 13 times to the right. Now I have the number for the bacteria, right? And here I have the function, so they need the time. So I would plug in this number of bacteria here. So 2.1 times 10 to the power 13 equals 5,000 times 1.65 to the power t. So they need the time. So I would divide both sides by 5,000 to isolate this number here. Now divided by 5,000. Sorry, I divided by 500, so I would divide by 10 again. So 4 2 and 8 zeros equals 1.65 to the power t. It's an exponential equation. I would take logarithm for both sides, and the base is 1.65. So time equal logarithm, the base is 1.65, and I need logarithm 4 2 with 8 zeros. 1 2 3 4 5 6 7 8. So the answer is 44 hours point 248. 44.248 hours. Don't round the time, leave it decimal, it's fine because it's continuous data. Continuous data can have decimal, like time, height, weight, length, width, area, volume. So leave it, don't round it. So it will take 44 hours, 0.248 to fill the container. I hope you liked this video. Thank you. Hello everyone, welcome to YouTube channel Math Everywhere. Here is Mr. Nizar, they call me Mr. Key. So this is exponential function, and it can come in math SLAA, also AI, also in HL, it can come in the exam. And you will need a calculator here, so it will come in paper 2. So this question is saying that a scientist is conducting an experiment of the growth of specific or species of bacteria. So P is the population, the number of bacteria. K is constant, we don't know how much is K. I think they will ask us to calculate it. T is time. Please pay attention to the units here. So always time is 0. This is the original function. So PT equals 1200 times K to the power T. So let's start. T here is the number of hours, so be careful. Here is the unit of T is hours. And K here is a positive constant. Be careful, don't choose any negative answer. Write down the value of P0. So question AI, they ask you to plug in time with 0. So P0 is 1200 times K to the power 0. Any number in the world, any number to the power 0 is 1. So the answer is 1200. AI. Interpret. What is this value mean? What does this value mean? What do you think this value mean? Always when time is 0, that means the initial. So the initial number of bacteria or population. So I got 2 marks for this question. So answer 1 mark, answer 1 mark. It's super easy. Question B, but before that I need to read. They said 3 hours after the experiment. That means when the time is 3 hours. The population was, so P3, after 3 hours, the population was 18,750. Get your calculator ready. Find K. Find K. So this is a question B. They need K. Plug in these numbers in the equation. So put, instead of T, 18,750 equals 1,200 times K to the power 3. So this looks like an exponential equation, so I will need logarithms later on, but first I will divide both sides by 1200 to isolate k. So k cubed equals, I'm sorry, I said something wrong here. K is the base, so there is now no variable in the exponent, so it's not an exponential equation. This is a cubic equation because you have k cubed. So I would need no logarithms here. I would need the cubed root, opposite of cubed. First, let me divide 18,750 by 1,200. So the answer is 15.625. 15.625. Since k cubed equals this, so I would take cubed root of both sides. So I will delete this. So k would be the cubed root. You see it here? Shift cubed root of the answer, 2.5. They said it's a positive number, which is 2.5. This question has 2 marks, so I would get method 1 mark and answer 1 mark. It's so easy. Question C, find the population of the bacteria after 1 hour and 30 minutes. So they gave you the time here, an hour and a half, so 1.5. Find the number of population, so they need P. Plug in the original equation, but now you know K is 2.5. So you will plug in K with 2.5 and the time is 1.5 because they said an hour and a half. So P 1.5 equals 1,200 times 2.5 to the power T, which is 1.5. Get your calculator ready. So 1,200 times 2.5 to the power 1.5, because they said 1 hour and 30 minutes, which is 1 hour and a half. Now, number of bacteria cannot be decimal. Please, when you are calculating number of people, number of population, number of animals, please round down always, like number of cars, number of bags, round down, because the number of bacteria cannot be decimal. Even if it's 0.9, round it down, because you cannot add life to populations, right? So here I would say 4,743 bacteria. Now let's go next. Here they said the scientist conducts a second experiment with a different species of bacteria. The population has this. Now they gave you the base. Now this is an exponential equation or function because the power is t. S is the population of the bacteria. The type of it is S. T is, they didn't mention, I think here, yeah, it's in hours also. Both began. Find the value of T when the two populations of bacteria are equal. That means I need to make these two equations equal each other, because they said the number of population here will be equal to the number of population here, so you have to solve it. So I would say PT equals, this is a question D, PT equals ST. So I have 1,200 times K, which is 2.5 to the power T, equals 5,000 times 1.65 to the power T. So I need to find T. Okay? So now, how to do that? It's weird, right? I would isolate these two numbers, but I need to put them together. But everything is multiplication, so I cannot move anything to the other side. Let me divide both sides by 5,000. And also divide both sides by 2.5 to the power T. You can do that in math. Now I deleted this. Now here I isolated the numbers. 1,200 divided by 5,000, which is 0.24. So I have 0.24 equals 1.65 to the power t over 2.5 to the power t. In math, if you have something like that, you can raise both of them to the power t because they have the same power. So you can put 1.65 over 2.5, both to the power t. Let's find how much is this. 1.65 divided by 2.5 equals 0.66 to the power t. So now I am having an exponential equation. So I need to isolate t. Since this is an exponential equation, the variable is in the exponent. What is opposite of exponent? Logarithm. I will take logarithm for both sides, but the base is 0.66, so they will cancel each other. So now the time is logarithm 0.24 for the base